In this lesson, we're going to look at what's called a scatter plot, and going along with that, the line or possibly curve of best fit. For grade 9, we're only interested in lines as in straight things, but we will see how, what a curve looks like as well in this one, just because, then we can differentiate between curves and lines, and also sort of looks ahead a little bit to grade 10 when you are working on curves. So here's a couple definitions. Scatter plot. Well, a scatter plot is a graph of points, in other words, ordered pairs. They're not necessarily in a line or a curve. Often the points do look scattered. So if you look down here, ignore this black line for now, but just look at the dots. That's a scatter plot. They're just a bunch of dots all over the page, but they're ordered pairs, right? For example, if I wanted to look at this dot right here, it would be the ordered pair 30 approximately, because of the x-coordinates lining up with that, and 10 approximately. It's not exact. I'm just giving you an example. So that's approximately the ordered pair 30, 10. Every one of those dots can be represented with an ordered pair. So that's what a scatter plot is. A line of best fit is a line going through the average of the points. In other words, as close to the middle of the points as possible. It's sometimes called a trend line because it shows the trend of the data. In other words, we read graphs like we read books here in Canada from left to right. We read words from left to right. We should read graphs for the most part from left to right. So going from this side of the graph to this side of the graph, we can see what the trend is. Are the dots generally getting higher? Are they generally getting lower? Are they generally staying the same? That's why it's called a trend line, because we can see what the trend is of what's going on. Now here's an example of a line of best fit over here on the right. We got some dots that are pretty close together, and we got this line which is getting as close to them as possible, but it can't touch them all. It's impossible to touch them all because unless I make my line really thick, but that's cheating, right? I'm just trying to get as close as possible to all the lines go down the middle. This is an example of what's not a line of best fit because it's not going down the middle. It should really be following the trend of the points, going down the middle as much as possible. Let me draw what I think, my best guess at the line of best fit would be. I'd probably start it somewhere around here, around 10, and it would probably be something like this. Now, I'm just basing that on the fact that there's a fairly equal, estimate. I'm estimating there's a fairly equal number of dots above the line as below the line. Also, the dots do seem to be trending upwards as I go from left to right on the graph. The dots generally seem to be going up. For example, here on the left side of the graph, we got dots down here low. But over here on the right side of the graph, there's no dots down here, are there? The lowest dots over on the right side of the graph are these ones. So definitely there seems to be a trend going upwards overall. That would be my line of best fit. There's some rules when you're drawing your own line of best fit. Try to follow the trend, use a ruler. The line may or may not pass through the origin. Notice how neither of these graphs go through the origin. Remember, this is the origin right here. Here, here. Neither the red one that I drew on the left nor the black one that was already there on the right, neither of those go through the origin. Lines of best fit do not have to go through the origin. A line should pass through as many points as possible, though, leaving an equal amount on either side of the line. Again, that's what I aimed to do. I don't really worry about going through as many points as possible because that's kind of tough. But I definitely try to put it down the middle as much as possible following the trend. So here's an example. Draw a line of best fit on the New York Liberty 2005 graph. So this is showing points scored on the vertical axis, time played in minutes. The letters represent different team members. So this is some sort of team sport. I have to admit I don't know what the New York Liberty 2005 is, but obviously involves a team. Each different letter is a team member, and then this And again, for each team member, how many minutes did they play? How many points did they score? So, ignoring all that for now, just drawing the line of best fit. This one does, to me, look like it starts at 0-0, and that makes sense, right? Because if you play, if you play 0 minutes, then you're probably going to score 0 points. But even still, it doesn't have to be at 0-0. It doesn't have to go through 0-0. A line of best fit should just follow the pattern that's going on that you see. And for me, I think it's pretty much like this. Again, it's open to interpretation, open to argument. You could say that, no, Mr. Begg, I think that the line of best fit is more something like this. Right? Maybe you think it's a little higher, or maybe you think it's a little bit lower. You know, you can, within range, you can argue it. I would disagree. I did draw the one that I thought was best. I'm going to get rid of these other two. But, you know, I'm willing to accept some variation. It's not that precise. What does the line of best fit allow us to do? Well, what it does is it lets us make predictions now. Say, again, maybe they have this New York Liberty in 2006. Then I can predict, well, okay, if someone plays in this in 2006, based on the previous data, if they play for 600 minutes, how many points should I expect that they're going to score? Well, 600 is here. Now I can look at this graph and go, oh, okay. Well, 600, they should score about 200 points based on that data that I've got. Okay, so that's what it allows us to do. And really, when you get down to it, that's the whole point for everything we've been doing for this math course, for all these things to do with lines. When we find a relation between things, then we can make predictions about what's going to happen. Math isn't just an exercise of playing with numbers for the purpose of torturing teenagers. It is used in the real world in so many things, mostly to allow us to make predictions or to design things or just to do all kinds of things that are useful to human beings. The scatterplot shows the value data for a snowmobile based on its age. Draw a line of best fit. Is there a trend in the data? Explain. Again, just to interpret this graph, imagine every one of these dots represents a different snowmobile. So maybe someone had some sort of online trader, and they just found a bunch of snowmobiles on there, found the age of them, found the cost that they were selling for, plotted it. It's not going to be a straight line because different conditions are involved. Some snowmobiles are in better condition than others. Some people are just better salesmen, so they're going to get more money for it. Some people don't care, and they're just going to sell it as cheap as possible. So there's going to be some variation, right? Well, that's what gives us a scatter plot. But we do know that in general, as they get older, they aren't worth as much. So yes, there's going to be a trend. So jump ahead and answer that part of the question before I even draw the line of best fit. We can tell before we draw the line. I don't have to have the line drawn there in order to answer the second part. But definitely there's a trend. It's going downwards. Value decreases over time. Any vehicle, snowmobile, motorcycle, car, truck, airplane, their value goes down over time. And that's what this trend is showing. Some scatter plots show a trend, but the points do not lie in a straight line. So a line of best fit is not appropriate. However, the data can be approximated by a curve. Therefore, a curve of best fit is appropriate or suitable. To draw a curve of best fit, you still want to draw a smooth curve that passes through as many points as possible. So it should be pretty obvious that it's making a curve. When I look at this population of caribou graph, it's a pretty obvious curve that I could draw through it. If I look back at this one, I would not try to draw a curve of best fit on this one. Like, I'm not going to try to do something like this. It's not connect the dots, right? So I'm not doing, that's not what we mean by curve of best fit. There should be some sort of obvious curve going on like there is in this one. So this caribou one, the way they're spread out like this, it is possible for me to hit every single one of these with my dots with my line. And that is, but that is a curve of best fit. It makes sense to draw a curve for that one. It would not make sense to try to force a line of best fit on this one, because that's really not what the relation is. Sure, I could do this, and it's like, wow, yeah, look, there's some dots above and some dots below, and yeah, I've got the general trend. But really, that's not what's happening. And then if I would extend it, of course, it's just going to get worse, right? If this graph kept going this way, and then the real graph kept going this way, then they're going to get farther and farther apart. So it is important to get a curve of best fit, draw a curve of best fit when that's what you're looking for, and draw a line of best fit. So pick the appropriate tool. Describe the trend that the data shows. Sure. Well, it's going upward. It's a positive trend going upward on the graph anyway. And I'd also say it's accelerating. Oops, looked away for a second. Accelerating. What do I mean by that? Well, what I mean is, as time goes by, it's going up quicker. It's going up faster in 1996 than it was in 1980. And I've already drawn the curve of best fit, so there you have that. The last one, the soccer ball, kicked up into the air from the ground. The height of the ball measured regular time intervals. So these are ordered pairs, right? Here's an ordered pair, here's an ordered pair. So we need to graph this data, draw a curve of best fit. We can imagine what this graph is going to look like. I mean, picture a soccer ball kicked in the air, and it's time versus height. What do you think the graph's going to look like? Well, we've all seen gravity at work. It's going to go up, and it's going to come back down. And so we have an idea of what the graph's going to look like. Let's see. Let's put a quick scale on here. I'm going to put 0.4, 0.8. I'll go up by 0.2s. So this is time in seconds. This is height over here in meters. I'll go up like this. And then I got my ordered pairs. So I had the ordered pair 0, 0. What else did I have? 0.2 and 2.2. And 0.4 and 4. 0.6 and 5.4, 0.8 and 6.5, 1 and 7.1, 1.2, 7.3, 1.4, 7.2, and 1.6, 6.7. Okay, there's my ordered pairs. Let's draw a curve through it. Again, since we know what to expect, it's sort of easy to just see what the trend is. It's going up, and then it's coming back down. And it stops. That's where data stops, but I think we can expect that it's going to keep heading down unless gravity is suddenly suspended. It's going to keep coming down again until it hits the ground. We could even predict where it's going to hit the ground, you know, how long it's going to be. It'll probably take a little over 2 seconds if this trend continues for it to hit the ground, right? What trend does the data show? Well, the trend goes up, then back down. When is the ball at its greatest height? Well, it appears to be it's about 1.2 seconds, right? When is the ball at 5 meters? Well, 5 meters is here, So it's going to be, if I go down to this, just under 0.6 seconds, but more than 0.5 seconds, so maybe 0.55 seconds, something like that. Now the funny thing is, since it comes back down, it actually will be at 5 meters again. If we try to make this trend continue, then I think that it's safe to say that somewhere around 1.8 seconds, it's going to be back down at 5 meters. When does the ball hit the ground? Well, now we're extending our graph a bit more. It's somewhere around 2 seconds, maybe 2.1, 2.2. Again, now we're just, it's guesswork here, right? But we can definitely get an idea. We can make a prediction, and that's the whole point.